Hey Matrix, welcome back to the series of Maths Paper 2 where we're going through the November 2020 past paper. Today we're looking at question 5. If you don't have the paper, then please pause the video now. You can find a link in the description where you can then go and download the paper as well as the memo. Once you have the paper, then we can continue with the question. Okay, let's get started with question 5. So question 5 is looking at two trigonometric functions. So we're looking at f of x equals negative a half cos x, and we've got g of x equals to sine of x plus 30 degrees, okay? Note that it's only for x values in 0 to 180 degrees that we are considering here. Okay, then they've also given us the point A, which is over here, the intersection of the two graphs. So we can see from f here already that we're going to be starting down here at negative a half, and g of x we've shifted 30 degrees to the left. Okay, remember it's positive in here, so we've shifted it left. If it was a negative, we would have shifted it right. Okay, so let's get started. So 5.1 says write down the period of g. Okay, now remember the definition of period is how long to complete one full wave. Okay, that means we starting at one point and ending back at the same point just further down the line. As you can see, we've completed one full wave. Okay, so the period for g, in this case, we can see that g is sine. Now the only thing that's happened to sine is we've shifted the graph to the left, but we haven't done anything to the period at all. Okay, so the period is still going to stay 360 degrees. Okay, so that's how long it's going to take to complete one full wave. Okay, now 5.2 says write down the amplitude of f. Now remember, the amplitude of a function is the distance from the x-axis to the maximum or the minimum of the function. Okay, so in this case for the trig function, it's going to be where our function reaches its maximum height or where it reaches its minimum height, or the trough as we call it. So remember from grade 10 that normally the number in front of the function indicates its amplitude for a cos graph, okay? But remember its distance, so we're not going to incorporate the negative, we're going to take the absolute value of that. So remember the absolute value of a number is just equal to the positive version of that number. Okay, so my amplitude is a half. Now 5.3 says determine the following: f of 180 minus g of 180. Okay, so just substitute the value of 180 degrees into your two functions and minus them off from each other. So we're going to have negative a half of cos 180 degrees. Okay, that's my f function, minus my g function, which is sine 180 plus 30. Okay, now cos of 180 degrees, okay, is negative 1. Okay, why are we sitting in the second quadrant on the x-axis? So this is going to become negative a half minus 1. Okay, now we're going to end up with sine of 210 degrees. Okay, now 210 degrees, we are sitting in the third quadrant, so therefore sine will be negative. Okay, and we're dealing with sine of 30, which is then, let me get it here, it's then a half. Okay, so we're going to end up with a half minus a half. Okay, so we have a half plus a half because of these two negatives, which is then going to equal to 1. Okay, now looking at 5.4, okay, please note that 5.4 is asking use the graphs to determine the values of x in the interval where x is an element of 0 to 180. So we're only dealing from 0 to 180, for which the following holds. Okay, so for 5.4.1 says f of x minus 10 equals g of x minus 10. So once again, you can substitute that into your graph or into your functions if you want and try and work it out that way, or we can notice that if we look at this, f of x equals to g of x. Okay, we have that. Why? It's given over here at the point A. A, they told us, is where f of x intersects g of x, which means they equal at that exact point. But now look what's happened. We've said x minus 10 degrees and x minus 10 degrees. So both graphs have shifted by 10 degrees to the right, okay, because of the negative. So because it's x minus 10, we've shifted right. Okay, so look at your coordinates over here. My x coordinate for A is 130.9. But now they're telling us that my graph's shifting to the right by 10 degrees, which means all I need to do is take that value over there, which is the intersecting point, and add 10 degrees, and that becomes the new point where the two graphs intersect each other. So we are going to have the x value for A. So A's x value equals to 130.9 degrees, and all we're going to do is add 10 degrees onto it. Okay, the thing is, you need to remember the negative means we're moving right, so we increase our degrees. Therefore, we have 140.9 degrees. Okay, and that's your x value. Now, 5.4.2, okay, a little bit more of a interesting one that they've given us. Square root of 3 sine x plus cos x must be greater or equal to 1. Okay, note that it's strictly, not strictly greater, but greater than or equal to. So we've been given these two functions, so we need to relate this expression to those two functions in a way. So how I thought about this first, I've got a cos function over here, and I've got a cos function up top here. Okay, but the cos function has an amplitude of a half. Okay, so let's see what happens if I create this cos function and that cos function, if I can relate them. So what I'm going to do is I'm going to divide both sides of the inequality by a half. So 5.4.2 says we have the square root of 3 sine x plus cos x must be greater than or equal to 1. Okay, so I'm going to divide both sides by a half, so I'll have square root 3 over 2 sine of x plus a half cos of x must be greater or equal to a half. Okay, now we know that with our special angles there is a angle for a half and an angle for square root 3 over 2. Okay, so if you use your special angle triangles, you are going to get to the square root of 3 over 2 is equivalent to cos of 30 degrees. Okay, and a half, in this case what we're looking for, is something that's going to match this cos 30 degrees, but we need a sine value, and I'll show you now why. So if you remember from your special angles, a half is going to equal to sine of 30 degrees. Okay, now let's substitute that in and see what we get. So I'm going to have cos 30 degrees sine of x plus sine of 30 degrees cos of x. Okay, now that should look familiar to our double angle rule. Okay, the only thing is now we have cos in front instead of sine and cos. Doesn't matter because of multiplication. The important thing is here the plus sign. So we can see that we have a double angle rule here. So I'm going to change this to sine of 30 degrees plus x. Okay, and that must be greater or equal to 1. Now, if you look back at your original functions that were given, here we have sine of x plus 30 degrees, and here we have sine of 30 degrees plus x. Okay, in this case it's the same thing because they're both positive values. So what the question is actually asking is, where is g of x greater or equal to 1? Okay, and if you go and look on your graph, greater or equal to a half, not 1, sorry. Where is that greater or equal to a half. So we can see over here we're greater than or equal to a half because we're positive, until we come down to where, okay, so we have figured out now that g of x must be greater or equal to a half. Okay, and g of x is sine of 30 degrees plus x. Now take sine of x. What is sine of x? What is the value of it when it's equal to a half? So if you plug that into your calculator, if we find where sine is a half, we're going to get 30 degrees. Okay, and if we continue moving down, okay, we're going to get 30 degrees, and then we're going to get 150 degrees. So we'll have 30 degrees plus x greater or equal, is equal to, we're changing it to the equality, to 150 degrees. Therefore, x is going to equal 120 degrees because the period has, the function has shifted to the left. Therefore, we can see that x will be greater and equal to 0. That's when the function will be greater than a half. And it's where it's greater or equal to 120 degrees. Okay, and that's how we go about solving this one. Okay, if you found today's video helpful, then please leave a thumbs up on the video. Please consider subscribing to the channel as well. Then you'll get notifications for when the next videos come out. Please go check out the channel as well. It's got physics, chemistry, and maths paper 1 videos. And if you have any questions regarding this question, please leave them in the comment section below. Thanks for watching.